Hi, Year Sevens. I've just created this short video for you just to start us off for our next lesson. So, next lesson together, we are going to be drawing line graphs to represent data. This is just a quick overview of that skill. So, when you come to class, you're going to be fully prepared to get started on the work and not have any homework at the end of the lesson. That's what we all want. Hopefully, some of you have already, or all of you, have already done line graphs previously, perhaps year 5 or 6. But if it's a new skill for you, that's okay. Watch the video carefully and know that the reason why we create these videos for you is so you can go back and listen to information a second time if you need to. So we'll get started. Firstly, what is a line graph? A line graph displays information as a series of points on a graph that are joined to form a line. Now, a line graph can be drawn by hand, which is what we're going to be doing in our next class, or by using a spreadsheet program such as Excel. Why are line graphs useful? Line graphs are very useful to show change over time. They can show a single set of data, or they can show multiple sets of data. If we have two line graphs next to each other showing different sets of data over the course of a period of time, this can help us to compare similarities and differences between the two sets of data. When data is presented in a visual form like a graph, it's actually a lot easier for people to read, and it's a lot easier for us to identify similarities and differences. So I'm going to model how to draw a line graph for you now, but first I'd like to tell you what a good line graph has. So it's really good for a line graph, if you're drawing it by hand, to draw it in pencil. The chances of you having to rub something out and do it again are pretty high. Most people have to do that. So always draw your line graph in pencil to begin. You should also always have an appropriate scale to show data clearly. So if you are drawing a line graph by hand, you have to make sure you're ruling out your scale. Your scale should be evenly spaced. Using a centimeter or half centimeter spaces is usually good. And if you do have access to graph paper, that is the best thing to use. A good line graph always has labeled axes. So the axes are the two lines, the vertical line and the horizontal line, that is indicating where the data sits. So there's a horizontal and a vertical axis. The x axis is the horizontal one. The y axis is the vertical one, and I'll go through that a little bit later on as well. Now, a good line graph uses small dots that are joined by a line to make a smooth curve. So your line graph should be really easy to read because the line should connect all of the dots of data together. There should also be a legend included if necessary. And a clear and accurate title is necessary to explain the purpose of the graph. This should be clear to anyone that is looking at a line graph. A title is very important. You should also put in the source of the data. So, where did you get this information from? It's important that with any subject that you're studying, history, geography, anything at all, you should always be putting in where you find your information. You want to make sure that you're never plagiarizing data, plagiarizing information. You're always telling people where you got it from so that your resources are verified. So, I'm going to run you through how to draw a line graph. The things that you're going to need to draw a line graph are, first of all, data. Now, I've got some data here that we're going to use in this model. Graph paper is what you're going to need as well. You're going to need a pencil and you're going to need a ruler. So when we go to our next class, you must make sure that you have a pencil and a ruler. I will supply you with graph paper and I will also supply you with data to use. So the data that I'm going to be talking about today is the use of rainwater tanks by household from 2001 to 2010. Now you can see this data presents us with 4 data points. The data that was collected in 2001, data from 2004, data from 2007, and data from 2010. So let's continue. So step 1 is to draw your axes, okay? After you've selected the data that you're going to compare and interpret, you draw the horizontal and vertical axes using a ruler. These should be evenly spaced and then label the years along the horizontal axes. You need to look carefully at your range of data and work out appropriate scale for the vertical axes Then evenly space and label this information on the axes. You start at 0 in the bottom left-hand corner. So both axes start at 0, and that's where the axes will join. From there, they should be evenly spaced out on both axes. You can see on the example I've got here, it's using graph paper to scale the axes, and you can see each square indicates one spot along on both axes. That is really clear information. The reason why we do that is so that it's easy for someone to read. If someone who has not created the graph comes along and wants to read it, it should be easy for them to do so. So next step is for you to plot your statistics. You should draw a dot at the point where the year on the horizontal axes meet the relevant position on the vertical axis. So you can see on now, this is an example graph here. You can see on this one here that the first red dot is sort of sitting at about a 1 on the horizontal axis. So it's sitting between 0 and 2 on the horizontal axis. And on the vertical axis, I'd say it's sitting a little bit above 300. So it's closer to 400 than 200. So it's about 350. Now, this is a generic graph, so don't worry too much about this information. It's just showing you what it means when it says to plot your statistics. So you draw your dots first on the relevant points. You need to make sure that they mark up correctly on both the horizontal axes and the vertical axes. You should then join all of the dots once you've plotted the statistics. So I'm just going to quickly go back to our data. Here we are. So the first one, 2001, your first point would indicate 16%. Now, if we were doing this correctly, which we want to, you're not going to have each point on their vertical axes as 16, 17, 19, and 26. What you should do instead is you should have it from perhaps a 5, 10, 15, 20, 25, 30, or perhaps even 10, 15, 20, 25, 30. And you should indicate as clearly as you can where 16 sits on that axis, where 17 sits, where 19 sits, and where 26 sits. Okay? Because we want those increments to be logical, and we want them to be evenly spaced. I hope that makes sense. If not, don't stress, because you can always ask questions in class. So we'll go back to our step 2, plotting our statistics. Now, after you've plotted your statistics and you've drawn the line between each plot point, you're going to move on to step 3, which is to add a title and a source to the graph. Now, for the particular data that we were using, the title would be something like the use of rainwater tanks by household 2001 to 2010. The title, it's not very creative, but it does give a very clear indication of what I'm showing on my graph. You should also add the source. Now, the source for this particular data, if we go back to our data here, you can see down the bottom that the data is indicated as being from the Australian Bureau of Statistics. Now, we would also include that information on the graph that we create, just to make sure that we're covering all our bases and we're acknowledging where our data comes from. So, after you've done all of that, you need to go back. Step 4 is the most important step. You need to check and make sure that you've included all of the information that you need to. So go back and check each step and make sure you've done each one correctly. So perhaps you would do a checklist for yourself. You might say, have you labeled all of the axes? Yes. Have you provided a clear title and source? Yes. Have you plotted the data accurately? Now, that one you might need to double check because that can be difficult. You want to make sure that your representation of data is accurate. You also want to ask yourself, have you joined the points with a smooth line? So I would say the best practice is to use a ruler to join your plotted points. So guys, I hope this is helpful. I know that it has been a long video, almost 10 minutes long. Thank you for paying attention, and I'm looking forward to seeing you in our next class so you can have a go at creating your own line graph using data that I've provided. Now, I'm not requiring you to do anything from this video except to submit done on Schoology, so I know that you've watched the video. Thank you, and I'll see you in class.